Hello. All right. For 9F, we're going to be talking about the quadratic formula. So just to kind of start off and get us acquainted with what to expect, we're actually going to start with simplifying radicals into simplest radical form first. All right. So first we have the square root of 64. So this is a perfect square, which means when you take the square root, it's just going to be a whole number. So it's just plus or minus 8. So this is all we're expected on this first one. Now for your second one, we have the square root of 48. So for this one, I'm going to do my factor tree and I'm going to split it into, say, 4 and 12. Then 12 can split into, say, 4 and 3. And then I have a pair of 4s right here. And then I have a leftover 3. So this is going to be equal to plus or minus 4 root 3. So just remember, you don't have to use the same factors that I'm using. If you want to do 2 and 24 and then break 24 into like 2 and 12 and then 2 and 6 and then 2 and 3 and so on and so on, you can't. You'll get the same exact thing, or you should. All right, so now for this next one over here, we have 2 root 24 times 3 root 12. So I'm going to be a little bit more strategic about how I solve this one. I'm not going to do a factor tree. I'm going to do a different method. All right, so first thing I'm going to do is group the 2 and the 3 together, and then I'm going to group the 24 and the 12 together under the same radical. All right, so what I'm going to do is 2 times 3, and then inside the radical, I have 24 times 12. So remember, just like in the factor tree, we're looking for pairs. So inside this radical, I'm still going to be looking for pairs. All right, so 2 times 3 is going to give you 6. And then over here in the radical, I'm actually going to split up this 24. So this 24, I'm going to rewrite as 2 and 12 so that I still have that 12 here. Now I have a pair of 12s right here. So that pair of 12s is going to come outside of the radical. So I'm going to have 6 times that 12. And then inside the radical, I still have that 2 left. All right, so then 6 times 12, that's going to give you 72 times the square root of 2. So if you want to start solving the radical problems using this instead of a factor tree, you can. Just know that some of those factors can get easily lost. Some of them, depending on how you organize it, can be a mess. So just be very careful if you do it this way. But if you want to just do the same old factor tree that we've been doing, you're more than welcome to as well. Just be careful with the grouping. All right, so now we're going to get into the actual quadratic formula itself. So this is the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So if you look here, you'll see that the b squared minus 4ac is in purple. So that specific part of the quadratic formula is what we call the discriminant. So the discriminant is actually going to tell you how many solutions you will have. So remember, the quadratic equation can have at most 2 solutions. All right, so if you want to pause it here and write this down, you can. The solutions are going to tell you exactly, nope. The discriminant is going to tell you how many solutions you have. So over here, this kind of gives you the ins and outs of it. So if your discriminant is positive, or if it's bigger than 0, then you have 2 solutions. If it's equal to 0, you're only going to have 1 solution. And if it's negative, you're not going to have any real solutions. All right, so then also kind of gives you an idea of what to expect on the graph. So if you have 2 solutions, it should cross the x-axis twice. If it has 1 solution, the vertex is on the x-axis. It only crosses once. And if you have no real solutions, the parabola does not even cross the x-axis at any point. All right, so a question I get every time I teach this is, where the heck did that come from? It looks like someone smashed their head on a keyboard and said, that'll do. Well, it actually is mathematically derived from standard form. Okay. So I'm going to kind of go through this in detail. It's up to you if you really want to listen to it. I would say at least watch and listen. So those of you in, say, honors or higher level, I would pay attention because this could be a question on a test. All right. So when I take standard form, the first thing I'm going to do is I want to divide everything by a. All right, so I'm going to divide everything by a. So I'm going to have x squared plus b divided by a x plus c over a equals 0. So on the right side, 0 divided by a is still going to give you 0. All right, the next thing I want to do is I want to move over the c term. So subtract c over a on both sides. So when I do this, I'm actually about to complete the square. So I'm going to do x squared plus b divided by a x plus a square term. And that's going to equal negative c over a plus the square term. All right, so I need to find out what's going to go in that square term. So in there, I'm doing my b value. So I need to do b divided by 2 all squared. All right, now your b value is b divided by a. So when I write it out, I'm actually going to be writing b, that's not an a, over a. And I'm going to square that. So here, this is going to be the same as b over 2a all squared. So I'm actually going to leave it in this form when I plug it in over here, and then I'm actually going to simplify it later on. So here I'm going to have b over 2a squared, and then b over 2a squared. All right, so now I want to factor the left side and make it a perfect square. It's a perfect square trinomial. So when I factor, I'm going to take the square root of the first. So x, keep the sign of the second, and then square root of the last, which is b divided by 2a squared equals negative c over a plus b over 2a all squared. And at this point, this is when people start getting mad at me because there's hardly any numbers. It's all letters, but it's okay. All right, so now I'm still trying to solve for x. So essentially, I'm still working with completing the square problem. So just like before, I'm going to take the square root. So I'm going to have x plus b over 2a equals the square root. Remember, when you take the square root, we got to account for both the plus and minus, or the positive and negative value of it. All right, so we're going to have negative c over a plus b over 2a all squared. All right, so now inside the radical here, the b over 2a all squared, I'm going to go ahead and start simplifying this because I want to start cleaning up inside this radical. So x plus b over 2a, it's going to equal plus or minus the square root. All right, so I'm going to have negative c over a plus b squared over 4a squared. So just a reminder, whenever you square something, so b over 2a times b over 2a, I'm squaring it. I'm multiplying it times itself. So that's going to be b squared over 4a squared. All right, so that's where that came from. All right, so now I want to be able to combine these values into one fraction. So to do that, I need to have a common denominator. So I can multiply this first term times 4a over 4a so that I will have a 4a squared across the entire denominator. So I'm going to have x plus b over 2a equals plus or minus the square root. All right, so I have negative c over a, but I'm going to multiply it times 4a over 4a. So remember, that's the equivalent of still just multiplying by a form of 1. So it's really similar to the idea of rationalizing, but in this case, I'm really just multiplying by 1. So I'm not actually changing the value, I'm just changing the form. So just like rationalizing, I'm just changing the form. All right, so when I do that, what you're going to have left inside is you're going to have negative 4ac all over 4a squared plus b squared over 4a squared. All right, and now notice how we have the same denominator value here inside the radical. So that means I can combine those two fractions into the same fraction. All right, so I'm going to have x plus b over 2a. Wow, my handwriting is awful. And that's going to equal plus or minus the square root of negative 4ac plus b squared all over 4a squared. So now in the numerator up here, I'm going to go ahead and switch the order so that that b squared's first and I don't have that negative in the front. So x plus b over 2a equals plus or minus the square root. So I'm going to have b squared minus 4ac all over 4a squared. All right, so we're almost there, kind of. So I'm actually going to move you over here, and I'm going to move you over there so that I can work on this side. All right, so I'm going to copy this up here. All right, so this radical right here, I'm actually going to separate it into two separate radicals. So a radical in the numerator, and then a radical in the denominator. All right, so in the numerator, I have the square root of b squared minus 4ac, which is your discriminant. And then in the denominator, that 4a squared, that is a perfect square. So I can take the square root of that. So I'm going to have x plus b over 2a equals plus or minus square root of b squared minus 4ac. And then when I take the square root of 4a squared, you get 2a. All right, so now I can solve for x. So I'm going to subtract b over 2a on both sides. So I'm going to get x equals the opposite of b over 2a plus or minus square root of b squared minus 4ac all over 2a. Now, similar to before, we have 2a and 2a in the denominator. English is hard. So I can combine these into one fraction. All right, so I'm going to have opposite of b plus or minus square root b squared minus 4ac all over 2a. So there's our quadratic formula. So I promise it did not just like come out of nowhere. It was actually mathematically derived. All right. So we're actually going to be using this formula to find these solutions of our quadratic equations. So once you use the formula so many times, eventually you're just going to have it memorized, but I am going to have the formula written on pretty much every single problem. So once you write it, once you use it, it's going to be a lot easier to use. So if it makes you feel any better, the quadratic formula is really just about identifying the A, B, and C value, plugging it into the formula, and then just simplifying. All right. Okay, so looking here, we're actually going to start with just the discriminant. So just looking at part of the quadratic formula. So this is really the important part. So we're going to use the discriminant to determine how many solutions we're going to have. All right, so we're going to start with this first one over here. All right, so we have f of x equals x squared minus 9. So my a value is 1, my b value is 0, and I have a c value of negative 9. So just in case you're wondering what the heck that b value is, so this is the same as x squared plus 0x minus 9. So we're missing that b value, so that's why it's 0. All right, so I'm going to go ahead and plug into the discriminant. So that is the b squared minus 4ac. All right, so I'm going to plug in each value. So b squared, so 0 squared, minus 4 times my a value times my c value. All right, so 0 squared is just 0. And then I have negative 4 times 1 times negative 9. So that's going to give you a positive 36. So when you add everything together, you're going to get a positive 36. So remember, if your discriminant is positive, what that means is you're going to have 2 solutions. So some of your problems are just going to require you to identify how many solutions you have. All right, so looking at this next one, we're going to do the same idea. So we're identifying the a, b, and c values first. So we have an a value of 1, a b value of negative 10, and a c value of 25. So once again, start with your discriminant. All right, so I'm going to do b squared. So I'm going to have negative 10 squared minus 4 times your a value of 1 times your c value of 25. So negative 10 squared is going to give you a positive 100. Negative 4 times 1 times 25 is going to give you negative 100. So here we have 100 minus 100, which is going to give you 0. And what this implies is that we only have one solution. All right, and then we're going to do the same idea for this last one over here. So I would say pause here, try this one on your own. Or not, it's up to you. So we have an a value of 2, a b value of 3, and a c value of 7. All right, so we have b squared minus 4ac. All right, so now I'm going to plug in all my values. So I have 3 squared minus 4 times 2 times 7. So 3 squared is going to give you 9 minus 4 times 2, which is 8. 8 times 7, which is going to give you negative 56. All right, and then when you subtract, you're going to get negative 47. All right, and because it's negative, that implies that there's going to be no real solution. So remember, you have to say real. You can't just say no solution, because in this case, there are imaginary solutions. So there are solutions that exist, they just are imaginary. All right. So that's just finding the discriminant. So now we actually want to use the formula to find the actual solutions. All right, so one thing to make sure that you're aware of, all your equations that they give you have to be in standard form. So if they're not in standard form to begin with, you have to convert your equation before you even do the formula. All right, so over here, we're going to start with number 1. So once again, start with identifying your A, B, and C values. All right, so I'm going to do it over here. So your A value is 3, and we have a B value of 5, and a C value of -8. Oh, one thing I forgot to mention. We are going to write each solution in simplest radical form and rounded to the nearest hundredth. So I will say on any assessment that you could potentially see, the answers could be written in simplest radical form or in decimal form. So we're going to go ahead and just expect both for right now. But on the test or any assessment, we'll just expect one or the other. All right, so starting off, I went ahead and wrote down the quadratic formula for convenience. So I'm just going to take those A, B, and C values, and I'm just going to plug them into their respective place. All right, so I want the opposite of B, which means I want a -5, and plus or minus the square root of B squared minus 4 times A times C. And that's all over 2 times my A value. All right, so over here, I'm going to start writing it out. So I have -5 plus or minus the square root. So I'm going to focus on the discriminant here first. You always need to focus on the discriminant first. So 25, which is 5 squared. And then we have 4 times 3 times -8. All right, so here 4 times 3 was at 96. All right, I'm going to shorten this a little bit. Don't need all that. All over 2 times 3, which is going to give you 6. All right, so when I add everything in the discriminant together, so we're going to have -5 plus or minus the square root of 121 all over 6. So 121, that's a perfect square. So the square root of 121 is going to be 11. All right, so when I get to this point, -5 plus or minus 11 all over 6. So once you get it to either like simplest radical form and there's nothing else you can simplify, that's when you're going to separate it into 2 different answers. So that's when I use the arrows. All right, so we're going to have x equals -5 minus 11 over 6. And we're going to have, actually, here's something that will make your life a little bit easier. Literally just copy and paste. But the second one is addition. All right, so just to keep track, I'm also going to go ahead and change this color. So in the top, so -5 minus 11, it's going to give you -16 over 6. So when I simplify, if I divide by 2, then you're going to get -8 over 3. And then in the denominator, -5 plus 11 is going to give you 6 over 6, which is going to simplify to 1. All right, so we have our solutions, which are x equals -8/3, comma 1. All right, so real quick, I'm going to also show you some things in the calculator just as a refresher. All right, so here on your Casio, if I go to run matrix, let's get rid of all this garbage. All right, so I want to plug in -5 minus 11 all over 6. So just as a refresher, press this button here to open up a fraction. So then we're going to do -5 minus 11. It's going to be all over 6. So when you press enter, it gives you -8/3. Now here's the thing. We also want to be able to convert this into a decimal. So you're going to press the button right next to it, the fraction button, to the left of the parentheses and above the 8, and it will convert it to a decimal. So we are going to round it to the nearest hundredths. So that means we want 2 decimal places. All right, so I'm going to go back over here. So this is also equal to, I already lost it. What was it? Negative 2.67. Negative 2.67, comma 1. All right. So you could technically also do these in a calculator. So just to show you that as well, I'll go ahead and just do it for the first one so you guys can kind of get an idea. All right, so if I want to plug in just the quadratic formula with everything plugged in, just how it looks, what you can do is open up a fraction and just type everything in. So -5, and we'll start with the minus. So you'll have to do it 2 times, one with subtraction, one with addition. All right, so shift x squared to open up a radical. So 5 squared. Actually, just to get in the habit of it, I would say go ahead and put it in parentheses, even though for this one it doesn't matter. Then -4, parentheses 3, parentheses -8, close the parentheses. Then in the bottom, 2 parentheses 3. So there's your -8/3. And then once again, you can press this button here to turn it into a decimal. All right, so up here, now, instead of retyping everything, I'm going to just use the scroll. I'm going to delete and just change it to addition. And there's your 1. And you can't change it to a decimal because that's all it is. So in theory, yes, you can do these in the calculator. I encourage it for checking your work. I don't recommend relying on it. Of course, if I was in your shoes, I would also rely on it. But just, you also would want your practice with radicals just in case. All right, so going back over here. So I'll just do the iPad on that one, or the Casio on that one. The rest of these I'm going to solve by hand with the assistance of a calculator. So for number 2, so if you look and notice, this one's not even in standard form, so we have to convert it first. So I'm going to convert it by throwing over that 16 to the left side, because we want to set it equal to 0. So I'm going to have x squared minus 8x plus 16 equal to 0. So here, that's going to give us an a value of 1, a b value of -8, and a c value of 16. So I'm going to just copy and paste the quadratic formula over from the first question, not the second one. So this is what I'm going to start with. All right, so now I'm going to start filling in those values. So the opposite of b. So it's already negative, so I want the opposite. So I want the positive value. It's a terrible 8. There we go. So +8 plus or minus the square root. Put it in parentheses because of that negative. So -8 squared minus 4 times a times your c value. Alrighty, let's go ahead and extend that a little bit. And then all over 2 times your a value. So for the next part, I'm going to start simplifying and finding the discriminant. So I'm going to do 8 plus or minus the square root. -8 squared, it's going to give you positive 64. Then minus 4 times 1 times 16, which is 64. All right, and that's going to be all over 2. 2 times 1 is just 2. So here, we're going to have 8 plus or minus the square root of 0, since 64 minus 64 is 0. That's all over 2. I'm going to copy and paste. Let's do it right here. All right, so the square root of 0 is just 0. So we have 8 plus or minus 0 all over 2. Now keep in mind, if I add 0 or subtract 0, it's not going to change the value. So it's literally just going to be 8 over 2, which simplifies to 4. So because our discriminant was equal to 0, that's also an indicator we're only going to have one solution. We're not going to have two. All right, moving on. So number 3 here. So once again, start off by converting your equation to standard form. So adding 5x to both sides. So I'm going to have x squared plus 5x equals 104. And I still need to move over that 104. So subtract 104. So x squared plus 5x minus 104. That equals 0. So now I can find my a, b, and c values. So I have an a value of 1, a b value of 5, and a c value of negative 104. So I'm going to plug those into, that's not what I want. I'm going to plug those into my quadratic formula. I almost said standard form. And we're going to find those solutions. English is hard. Okay. So we want the opposite of b, so negative 5 plus or minus 5 squared minus 4 times a times negative 104. All right, and that's going to be all over 2 times your a value. All right, so over here, now we're going to start solving that discriminant. So we're going to have negative 5 plus or minus the square root. So 5 squared is going to give you 25. And then negative 4 times 1 times negative 104 is going to give you a positive 412. Nope, 16. Math is really hard. So just in case, 4 times 104, 416. I'd rather check just to be safe. All right, all over 2. So now what I'm going to do is I want to simplify that discriminant even more. Hello. There we go. So negative 5 plus or minus the square root of 441 all over 2. All right, so what I'm going to do next is I actually want to check to see if 441 is prime or composite so that I know if I need to put it in simplest radical form or not. So what I'm going to do is go over here to my handy dandy little Casio or calculator or whatever. And I'm going to plug in square root of 441. It's 21. So there you go. So in this case, it's a perfect square. So I'm going to have negative 5 plus or minus 21 over 2. All right, so this is where I'm going to split it into 2 different sections for my final solution. All right, so I'm going to have x equals negative 5 minus 21 all over 2. And remember, you're doing the same exact problem essentially right below it, but instead of subtraction, it is addition. I'm going to change the colors. All right, so in the top, you're going to have negative 5 minus 21, which is going to give you negative 26 all over 2, which is going to simplify to negative 13. And in the second one over here, we're going to have negative 5 plus 21, which is going to give you 16. And when that simplifies, you're going to get 8. So there's no simplest radical form. There's no decimal expansions or anything that we have to do. So you can simply write x equals negative 13, comma 8. All right. So I will say these problems can be pretty time consuming. I personally don't think they're terribly hard. It's just a lot of moving parts. Alrighty. So looking at this next one here, we have x squared minus 10x plus 26 equals 8. So we got to put it in standard form, so I have to move over that 8. So when we subtract, we're going to get so I'm going to have x squared minus 10x plus 18 equals 0. All right, so now I'm looking at my ABCs. So I'm going to have an A value of 1, a B value of negative 10, and a C value of 18. So once again, I'm going to start with a quadratic formula, which I'm going to copy and paste from over yonder. All right, and I'm going to start filling in those values. So the opposite of 10, so I want a positive 10 plus or minus the square root. So I want negative 10 parentheses squared minus 4 times 1 times 18. That's going to be all over 2 times 1. So when I start simplifying even more, we're going to have 10 plus or minus square root of 100, not square root. Negative 10 squared gives you 100. And then 4 times 18, let's say 2 times 36, so that's 72. So minus 72 all over 2. Alrighty, which then here, we're going to get 10 plus or minus the square root of, what is that, 28? Math is hard. All over 2. My brain is not working, y'all. It's the end of the day. All right, so now what I'm going to do, notice how we have the square root of 28. I know for sure that this can be broken down. So I'm going to go ahead and do my factor tree. So that's going to be 2 and 14, and then 2 and 7. We have a pair of 2's. So this can be rewritten as 2 root 7. So I'm going to copy and paste this value, but instead of writing the square root of 28, I'm actually going to write 2 root 7. All right, so this is kind of another version of simplifying that we're going to do. So notice how 10 and 2, both of those values in the numerator, both of those are divisible by the denominator, which means I can actually keep going and simplifying. So what that means is I'm going to separate. Whoops. All right, so I'm going to split up that numerator and I'm going to give each one of them their own denominator so that I can simplify. Oop, plus or minus. There we go. So 10 over 2 is going to simplify to 5. Then plus or minus 2 root 7 over 2 is just going to simplify to the square root of 7. So this is your final answer. This is your final simplified form. So just a note, if you did somehow stop here and call that your answer, you're still mathematically correct, but it's also the same as writing like 2 over 4. You could still simplify that as 1/2. So you're mathematically correct, but it's not in the right form. All right, moving on. 2 more. So number 5. So we got to put this in standard form. So I'm going to start by subtracting 23. I forgot to put the previous one in decimals. Dang it. So we're going to have negative x squared plus 10x minus 23 equals 0. Okay, I'm going to put a pin in this one. I need to go do the decimals over here. Whoopsies. Okay, so we're going to have x equals 5 minus the square root of 7. And then the same thing, but then addition. All right, so let's go ahead and use the Casio to find those decimal expansions. So over here, I'm going to do 5 minus the square root of 7. So of course, it's just going to give us the same thing, telling us it's already in simplest form, but I want to convert it to a decimal. So that's going to give us a value of 2.354, which is going to round to 2.35. All right, and then conversely, I want to do 5 plus the square root of 7, which of course is going to give us the radical form, convert it to a decimal, and then we're going to get 7.645, which is going to round to 7.65. So remember, we only want 2 decimal places. We want the nearest hundredth. But I will say, the more decimal places you include, the more accurate your answer is. All right, so if we want a simplest radical form, 5 plus or minus root 7 would be your answer. But if we want the decimal expansions, then it'd be 2.35 or 6.65, 7.65. Can't read, apparently. All right, now we're going back over here. So number 5. All right, so typically I would say your a value even needs to be 1, but in the case of quadratic formula, it doesn't matter. So I'm going to do an a value of -1, a b value of 10, and a c value of -23. Okie dokie, so I'm going to go steal the quadratic formula from over here. All right, so I'm going to fill in those gaps. So the opposite of b, so I want -10 plus or minus the square root of b squared minus 4a and c. All over 2a. Okie dokie. So here, when I start simplifying, we're going to have -10 plus or minus square root of 10 squared, which is 100. And then we're going to have minus, is that 46? So that's what, 92? Can I do math? I'm going to make sure. I'm tired. It's the end of the day. Yes. Just double checking. I'd rather check than write the wrong answer down. All right, and then all over 2 times -1, which is -2. So when I simplify, so -10 plus or minus the square root of 8 all over -2. All right, so 8, I need to simplify, or what's that called? Factor tree. So 2 and 4, 2 and 2, pair of 2's, left over 2, so 2 root 2. So even if you get that backwards, you'll still end up with the same answer. So remember, the pair numbers go on the outside. The leftovers go on the inside. So I'm going to replace the square root of 8 with 2 root 2. Pretty sure this problem was actually supposed to be something different. But we'll see. We'll see how this goes. All right, so I'm going to replace this with 2 root 2. All right, so once again, both of these values are divisible by the denominator, which means I can keep going. All right, so I'm going to have -10 over -2 plus or minus 2 root 2 over -2. So this is going to simplify to 5 plus or minus square root of 2. Now, here's the thing. We have a positive over a negative here, But because of the plus or minus, it accounts for both, so you don't even have to worry about it. All right, so if I was looking for simplest radical form, this would be our final answer, but now we need to do the decimal expansion. So x equals 5 minus the square root of 2, and plus. All right, so I'm just going to do these really quick over here on the side. So 5 minus the square root of 2. Decimal expansion is going to be 3.59. And then down below, when we are adding it, so 5 plus the square root of 2, it's going to give you 6.41. So whether you want the simplest radical form or the decimal form, there's both. All right. So number 6, sorry, I was looking at something. No. All right, so if you look at your equation here, it's not in standard form, so we have to convert it. So I'm going to add 6x on both sides. So I'm going to have x squared plus 6x minus 59 equals 0. All right, let me check something just real quick. So I want to make sure this problem is exactly the one we need. It is not. Okay, I need to change this problem a smidge. All right. So instead of this being, my apologies. So instead of this being minus 59, this needs to be plus 59. So I'm going to make that quick change. Then I'm going to solve this problem. All right, so we have an a value of 1, b value of 6, and a c value of positive 59. All right. I'm going to go steal my quadratic formula. Hello. Another email. All right, so we want the opposite of b, plus or minus the square root of 6 squared minus 4 times a times c. All right, and that's going to be all over 2 times a. All right, so when I start simplifying, I'm going to have negative 6 plus or minus the square root of 6 squared, which is 36. And then, what was that? My brain is not working. 60 times 4 is 240. Minus 4 is 236. Hello, my calculator is not working. Just to be sure, 4 times 59, 236. Minus 236. That's not a 3. All right, that's going to be all over 2. Now, keep in mind when we do this next part, we're going to have negative 6 plus or minus the square root of negative 200 all over 2. So this is the big problem area right here. So we cannot take the square root of a negative number. So automatically what that means is we are going to have no real solution. So for any Algebra 2 folks out there, you could find the complex solutions. Just remember to find the square root of -1, you're going to be using I. So that means you're going to be solving for 200I and then simplifying from there. So have a blast.